the stress making you sick?
No,
Or
I like
allergies?
the airplane.
Oh, yeah.
I like it just as a detail.
Okay, so it says let f and g be the functions defined by, and then they give you f and g, and let R and S be the two regions enclosed by the graphs of f and g as shown in figure above. So part A asks you to find the sum of the areas of region R and S. So we're trying to find the area here and here and add them together. So we already know that area under a curve comes from an integral. So does area between two curves. And the formula for the area between two curves is you integrate top curve minus bottom curve. Kind of makes you think about it. I'm trying to find the difference between the area from the top curve all the way to the x-axis and the bottom curve all the way to the x-axis. So the area between them is the difference between those two things. So you just integrate the top curve minus the bottom curve. So, and then the bounds are the x values where they intersect. So for R, we would go from 0 to whatever the x value is for this point of intersection. From S, we would go from that x value to 2. So we have to do two integrals because we have two separate areas here. That's why it says find the sum. We're going to find the area of R by doing top minus bottom, the area of S by doing top minus bottom, and then we'll add them together. So we're going to put this in the calculator and decide which curve is which. Like, I don't know which of these is F and which of these is G. So we'll figure that out when we graph it in the calculator. And then in the first area R, the top curve is whatever this equation is, and the bottom curve is the other one. And then in S, they switch. S, what was the bottom curve for R is now the top curve. And then what was the top curve for R is now the bottom. So it sounds harder than it is. Once you figure out which, it's really easy to set up, and it's, in this case, it's a calculator problem. It's not always a calculator problem. For a long time it was, and then a few years ago they put it on the non-calculator part for a couple of years. Then went back to the calculator part. So we'll get both types. So let's look. So we're going to graph this. So I'm going to graph. Good morning, Anna. So I'm going to type this in. 1 plus x minus b2e x squared minus 2x. And x equals 6.5 plus 6x. And I'm going to change my window to just go from 0 to 2, since that's what the window is for on my paper. And then the y's, you can have it just go from like, actually I'm probably going to do like -1 to 2 and -1 to 4 or 5, something. Maybe -1 to 3. I don't know, just so I can kind of see. Yeah, so the graph looks something like that. But I'm going to change the window. So I'm going to go to window settings. And I'm going to go from -1 to 3. And -1 to 5. So I can see it a little bit more like what's on mine. Here. That's not right. What's the wrong one?
I think on the
Oh, it should be a plus. There we go. Okay. My window, I just set it to go a little bit like on here, the x's go 0 to 2 and the y's go from 0 to 4. So I just went a little bit past that. I just went from -1 to 3 for the x and -1 to 5 for the y's. So for x min, I put -1. You don't have to do that. I'm just trying to make it as much on my calculator as like it does on the paper. So I did -1 to 3, and I told it to count by 1. So that's what the x scale is. You can leave it auto. It doesn't matter. And then -1 to 5. Okay, so here's the R and S that we're talking about. So I can see in the first area, that G is the top curve and F is the bottom curve. And then in the second area, F is the top curve and G is the bottom curve. So the only thing I need to figure out is where they intersect, because that's going to be one of my bounds on my integrals when I do them in it. We're going to integrate from 0 to whatever that x value is, and then from that x value to 2. I'm going to go ahead and find that point of intersection. So I'm going to do menu, analyze graph, intersection. To the left and click, to the right and click. I'm going to save that x coordinate. Right, so once I get it, I'm going to hover over it and press Control menu. I'm going to store that. I'll store it as K. 1.03332. Everybody get that? Okay. So we're going to find the area of each of those little sections and then add them together. And we can actually do it all at once if we want to. So I'm going to remember that I stored F as F1 and G as F2. And in my graph up here, this curve, this is G. And this curve that goes up like this is F. And where they intersect, this is at 1.033, right, which I call K. Right? You call it whatever you want to. Got it? Okay, so here's how we're going to set this up. So for region R, we're going to integrate from 0 to, I called it K, whatever you called it, right? The 1.033, right? And we're going to do the top curve, which was G of X, or for me, the F2 curve, minus the bottom curve, which was F of X, or for me was F1. So this will give me the area of R. The area of a region that's between two curves. You integrate from where the curves first intersect to make the area to where they stop or where they intersect again, right? So we're talking about between these 2 points. That's where this area is. So those are going to make our bounds, and then we do the top curve minus the bottom curve. So, and then we're going to add from K to 2, the other x value is 2, F of X minus G of X, because they switch places in that. And this is what I have stored in F1. This is what I have stored in F2. And you want to make sure that you show your setup. So you don't have to do everything like I did. You don't have to tell them that this is R and this is S. You don't have to say F1 and F2, but you need to show that you were doing the integral from 0 to 1.033 of G minus F plus the integral from 1.033 to 2 of F minus G. And then that's what we're going to type into the calculator. So I'm going to go to my calculator screen. And I'm going to type in menu 4.2, or you can use a template, 0 to K of F2 of X minus F1 of X dx. You can just type in, or you can press the bar button right above number 9. But you can just type F1, like the letter F and the number 1. And then plus the integral from K to 2 of F1 of X minus F2 of X dx. 2.004. And if you don't get the answer, oh, I guess I didn't sure. Let me make sure that mine. Yeah, okay. And like I said, I'll make sure that's done on the day of the test. I'll make sure your calculators are set right. So I look at the scoring guide for this. This was 2015. Number 2. Ooh, yay, that part was worth 4 points. Alright, so let's see.
It was 1 point for the limit. That means the bound. So like knowing that, and you can see here that they called the point of intersection, they called the x coordinate A. And as long as you put somewhere, like you don't want to just put K or whatever on your answer without writing somewhere what K is. So like that's how come I put on here that K is 1, 3. If you just make a note of that somewhere so that they can see that that's what your K is, then you can use K in all the rest of the problem. But somewhere you got to show them what that K is. You don't have to keep saying every time K is 1.033. You'll just write it once. So that's what they did on the answer key here. They wrote that capital A was 1.033, and they used that in their integral. So you have to have the limits, then the two integrands, so that's knowing top curve minus bottom curve, which one's top and which one's bottom, and each of those integrals, and then your answer, right? So 4 of the 9 points were in part A. I wish I could, oh, let's see, we can see what the score distributions are. Scoring statistics. Let's see. So on question 2, the average number of points that people got on this question was 4.68. So we're already pretty much average just on part A without getting either of the other parts. Okay, so then part B is kind of a variation on what they usually ask. Annie asked if we were going to learn waters, right, yesterday. We are going to learn washers, and that's normally the kind of question that they ask. They didn't ask it last year. So I will show you washers in a second. They asked a variation of volume, though. Wash is a method for finding volume, which I'll show you in just a minute. There are 2 types of volumes they can ask about. They can ask about volumes that are created by revolving something. So like if they were to take this weird shape here and spin it around the x-axis, it would make like a 3D shape that had a really, really weird shape to it. And you can find volume of that shape using the washer method. They didn't ask the washer method last year, though. They asked what is called a volume with known cross sections, which in some ways is a little bit easier than a solid of revolution, about a solid that you create by revolving, and in some ways it's a little bit trickier. It just kind of depends on your preference, but that's just understanding what they're talking about. Once you understand what they're talking about, the actual problem itself is not that hard. So this says region 8S is the base of a solid whose cross sections perpendicular to the x-axis are squares. That's the important part, and that's the part that's kind of hard to understand. So I'm going to attempt to draw what they're talking about. I'm not the best artist, but let's say this is S here. Right? I'm just kind of tilting it a little bit so I can draw in 3 dimensions a little bit better. But they're saying you have cross sections, which I'm going to show you what the cross sections are in just a second, that are perpendicular to the x-axis. So they go this way, perpendicular to the x-axis. And they're in the shape of squares. So let me draw a few of these. I'm kind of try to connect them. Yeah, it's very strange. It's like it's a 3-dimensional shape. This is the base. And then there's like squares coming up out of base. All right, so it's a collection of a whole bunch of squares put together to make this solid shape. Let me see if I can do a better job of drawing it. It's a weird shape like this. So tilt it a little bit more so you can see a little bit better. Something kind of like that. It's just a really weird 3-dimensional shape. And find the volume of it, you just have to know to integrate the area of each cross section. In this case, the cross sections are squares. So how do you find the area of a square? Yeah, it's like, and since the base and the height of a square are the same, it's basically just the side squared, right? Oh. So we're going to integrate one of the sides of the squares squared. So here's what it would look like. So on part B, I'm going to explain it. And like I said, they do problems like this every year.